Hey, welcome back to another video. So in the last one, in the previous videos, we have looked at what exponents are and what does it mean when you have a negative exponential or when you have an irrational exponential and how you can solve them when you have different negative bases. But as you may already be aware that in mathematics, everything is governed by these mathematical laws that we all have to follow, right? And exponentials are no different. So within exponentials, they have these specific rules that we all have to abide with. And in this video, we will actually going to have a look at what those rules actually are and how to follow them and how to actually use them in exponentials. So first things first, let me just write it up. Index laws. There. And I will actually use a different color. I think I might use, let's say I use black. So the very first rule states that if you have a base raised to the power of a number and it is being multiplied with another number with the same number raised to another power, then you can actually, as long as the base is the same, then you can add the exponents. And let me just change my color black to white. And this is a very, very basic and one of the rules where a lot of people make a lot of mistakes. So let's take an example, right? Let's say 2 to the power of 2 being multiplied by 2 to the power of 3. That means that now if the base is the same, that means that you have 2 here and a 2 here. That means that I can rewrite it as 2 plus 3, and then it will be 2 to the power of a 5. On the other hand, let's say you had 2 to the power of a 3 multiplied by 2 to the power of a 4 multiplied by 2 to the power of a 1. Then, since the base is the same in all three of them, then you can just rewrite this as 3 to the 2 to the power of 3 plus 4 plus 1. 4, 5, 6, 7, and that would be 2 to the power of 8. Now, the most important thing is that you need to remember is that in this exponential, in the very last one, it is being raised to the power of a 1. Do not forget that. That is where many of the people make mistakes. So for example, if someone wrote to you 2 to the power of a 3 multiplied by 2, right? A lot of people, they just go in and they just write 2 to the power of 3, but in reality, it is 2 to the power of a 3 plus 1. Never ever forget the 1 that you have, this invisible 1 that you have on all these numbers. Then it will be 2 to the power of a 4. But let's say instead of 2, let's say if I had written 2 to the power of 2 multiplied by 3 to the power of a 2. You cannot add them together. The reason you can't add them together is because the base is not the same. So you cannot just rewrite this as 6 to the power of a 4. That's not really how it works. So that is like the very first index law that you have to remember. Let's move up to the second rule that we have to follow. That is, let me just put the number 2. That is that if you have a number being raised to an exponent and you have a bracket being raised to another power, then the powers can actually be multiplied with each other and you end up getting a to the power of x times y. And that is a very, yeah, of course, it's kind of like dealing with brackets, right? So it's a very common sense rule that you can easily remember. So that means that 2 to the power of 3, if that is being raised to the power of 2, then that means that this would be raised to the power of a 6. 3 to the power of a 2 being raised to the power of a 4, then that would just be raised to the power of 8. That means that you can multiply these powers with each other and they would just be the same. On the other hand, that is also something that we saw in our previous videos, that when you had something like a to the power of a 1 over n being raised to the power of a m, then you can just rewrite this as there. So that is actually what this rule actually also explains very, very clearly. Uh, let's move up to a third rule instead. Now I'll just make a line right here, so we don't really have to use the next page there. So 1, 2, and 3. The third one states that if you have a fraction that looks something like this, a to the power of x divided by a to the power of y, then you can actually just rewrite this as ax minus y. Uh, and there are actually two different rules, and I'll actually maybe, while we're at it, I'll also write the next one, which states that 1 over a to the power of x is the same as a to the power of a minus x. And that's exactly what we saw in our previous video, that if you have a negative exponential, that means that it just can be divided as 1 over that base to the power of the same exponent. So coming back to this rule, it's actually making use of this rule and this other one. So that means that as long as the base is the same, and I was to write 2 to the power of a 3 divided by 2 to the power of a 2, then I can just rewrite this as 2 to the power of a 3 minus 2. And that would just give me 2 to the power of a 1. 2 to the power of a 4 divided by 2 to the power of a 1. That would then be 2 to the power of a 4 minus 1 and 2 to the power of a 3. So as long as the base is the same, and I keep saying it again and again, that you can only allow the exponentials to interact with each other as long as the base is the same. If I had a case that looks something like this, then I cannot subtract the bases with each other. That's not possible. Why? Because you have completely different bases. The only way to solve that fraction would be to actually solve this power and then solve this power and then divide them just like how you would normally. But to understand this rule a bit more, in a much more clearer fashion, let me give you an example. And I'll actually explain it here. A to the power of x divided by a to the power of y. Now, using this rule number 4, I'm going to rewrite this as a to the power of x multiplied by, because it is being divided. Let me actually, just to make it even more clear for you, this can be rewritten as a to the power of x multiplied by 1 over a to the power of y, correct? Because if we multiply them together, then I would get up this fraction again. I can rewrite this fraction as using this rule, which states that a to the power of x multiplied by a to the power of a minus y. Now, I just said in the previous rule that if the base is the same, and they're being multiplied with each other, then we can add both of the exponents together. Coming back to this example, the base is the same, perfect. That means that I can just write a, and I can add the exponents together. Now this is a positive exponent, so that's fine. If I'm adding it, that means it has a negative sign. That means that I'll just have to subtract it and then minus y. So you end up getting this rule. So now, you have noticed that this rule is actually kind of like it's kind of built up. It's based upon two other rules that we have already seen now. So we turn this into a negative, and then since the base is the same, then we can of course add them together. And I hope you're not confused with why it became x minus 1, because in reality what we're doing is we are doing x plus minus y. And as you already know, that every time you have a situation like this, then you just multiply the signs together, and you end up getting x minus y. So that is the other rule that we wanted to look at. Moving on, let's take another example, or sorry, the next rule, which is the number 5. And it's actually a much simple rule that states that every time a number is raised to the power of 0, it is just 1. So regardless of what number you have in mind, you can have 5 to the power of 0, that would be 1. 10 to the power of 0, that would be 1. 100 to the power of 0, that would be 1. And let's just say I write a huge number to the power of 1, to the power of 0, that it will be 1. That is simply the definition. The only number that you cannot raise to the power of 0, that is actually 0 itself. So 0 to the power of 0 is not equal to 1, but in fact it is actually undefined. So you cannot raise 0 to the power of 0. That is the only exception, and I'll actually maybe write it on the top as well, where a is not equal to 0. But the a can be any other number. Any number that you can think of, raised to the power of 0, that will be 1. No questions asked. Moving on. Now the next rule is also kind of like a subset of the rule that we already have seen before. But let's say you have a times b times c to the power of an exponent. What this means is that this exponent applies to all three of them. So a to the power of x times by b to the power of x times by c to the power of x. Let me write it up. Now normally what it means in terms of numbering, like if I had 2 times 3 times 5 and I had raised to the power of 2, then I couldn't rewrite this as 2 to the power of 2, 3 to the power of 2, and 5 to the power of 2, right? But this rule is actually much more concentrated on if you are working with variables. Because in this case, you could also have multiplied all three of them together to begin with, and then raise that to the power of 2, and that would give you the exact same answer as this one. But on the other hand, if I had 2a being raised to the power of 2, then the rule is actually much more useful, because what this means is that you have 2 to the power of 2 multiplied by a to the power of 2. What the mistake that a lot of people make is that if they are asked, for example, in this case, many people they end up writing 4a and they just call it that, but that's wrong because it's actually 4a squared. Every number or variable that you have inside the bracket will have to be raised to the power if you're using brackets. The same goes for 5c. If I did cubed, then it would be 5 cubed times by c cubed. And it doesn't matter how many variables you have in that bracket. You have 10 variables, all 10 of them are raised to that power. You could also look it in another view, like the rule that we saw earlier, this one, that if you have a bracket, then the exponents are being multiplied with each other, right? So in this case, you could also argue that you have a 1 and you have a 1. So 2 is being multiplied with that 1 power that you already have. And that reminds me, like for example, let's say we had a 2 squared times by a squared to the power of a 2. Then you would actually have to multiply this power to that power. Then you get 2 to the power of 4 times by a to the power of 4. But that is essentially what the rule actually means. Let me just change the color again so I can write it up the next one. What number are we on? Oh, 6. So we are now on the 7th rule that you have to remember. If I have a fraction like a to the power of a b, and that is being raised to the power of a negative x, that is actually the same as writing b over a to the power of x. Now this one is a bit more, it's slightly more complicated rule than the ones that we saw before. But once you understand it, it's actually very simple. I've already told you before that if something is raised to the power of a negative x, then that just means this, right? Great. And I have told you that if something is raised to the power of an exponential, then we multiply them together, and that by this and this is the same, correct? Coming up to this rule again, let's start from this fraction, and I'll show you how you can actually end up in that fraction. So you have a divided by b to the power of a minus x. Okay, now since it is a bracket, and as you saw earlier, if you have a bracket, then the exponent applies to all of the numbers or variables within that bracket. So that means the negative x applies to a and it applies to b. So I will open up the brackets and I will have to write it as a to the power of a minus x, b to the power of a minus x. Now what does minus x means? It means this rule right here. So without further ado, let's write 1 over x and let's write 1 over b to the power of x. Now, if you have fractions within the fraction, the rule states that you need to multiply the numerator. It is like one of the division rules that you in fractions, that if you have two fractions, then you multiply the numerator with the reciprocal of the denominator. The reciprocal means that you turn it around. And that is exactly what we'll do here. So a to the power of x times by b to the power of x divided by 1. Because it was 1 over b over to the power of x, right? So the reciprocal of that is b to the power of x divided by 1. It is a simple multiplication. So b to the power of x divided by a to the power of x. Now, do you see any relation between this fraction and this fraction? And I bet you did realize that they're both being raised to the same power, just like they were doing in this case. Therefore, we can rewrite this as b divided by a bracket to the power of x, right? Because they're both being raised to the same power, that means that we can put a bracket and we can put the x on the top. So in that case, so now we have achieved this expression from this expression. So essentially, this one is just equal to this one. In simple terms, if I had 2 over 3 divided by minus 2, then I can actually just rewrite this as 3 over 2 to the power of 2. If I have 4 over 5 to the power of a minus 3, then I can just rewrite this as the reciprocal. So 5 over 4, and then we can change this negative to a positive, and then you get 3. And they are both exactly the same. And they are the same because, as we have proved right here above, that how you can go from this expression to the other expression. And that is actually just the other rule that that we wanted to show. And let me just change the color back. And let's go to the next page. Now the other rule that we have actually already seen before is 5, 6, 7 is that a to the power of m over n is actually just a to the power of n raised to the power of m, or a to the power of m raised to the power of 1 over n. And that is exactly what I'm not going to go in more detail into what this rule is, but you're more than welcome to go and watch the previous video that we have done explaining what this rule actually means. But the important thing for you to remember in this case is that that you can easily rewrite this into the brackets, just like we saw earlier, that they are exactly the same. So you're being multiplied by each other. So it doesn't matter if you raise this base to the power or you raise to the power to the exponent. Regardless, it's going to be the same. So these are actually the main rules that you need to remember in exponents. And every time you are solving a problem with exponentials, it is always a good idea to keep these ones in mind. And the most important, the summary of these rules is that you can only and only add or subtract the exponents as long as the base is the same. If the base is not the same, then you cannot have the exponentials interacting with each other. Just like we saw in the very first rule, that as long as the base is the same, only then can you add them together. If they are being divided with each other, then you can subtract them. But in a case where, for example, in this case, where you have three different types of bases, then you cannot add them together. Then you are kind of forced to solve them just like how you normally would solve in a normal case. And that is all for today. Thank you once again for watching. And if you did like the video, then do remember to like and subscribe to the channel, and stay tuned for more videos in mathematics. Thank you.